Good morning or afternoon, whenever you see this. We're doing 4-6. We're going to split it up into 2 days. We're going to do kind of an algebra version on day one, with lining up corresponding points and sides. And then we're also going to be looking at systems of equations with substitution with that. And then on day 2, we'll do proving things with HL. But on day 1, we're going to do one proof just to see how it works. Today's objective, to prove right triangles congruent using hypotenuse leg theorem. Up until now, you've had 4 others: side, 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 angle, angle, and angle, angle, side. And this is our 5th congruence, triangle congruence reason. And here I got a congruence and right triangles is what we're looking at. Theorem 4-6, hypotenuse leg. Remember, hypotenuse is the longest side in the right triangle, opposite the right angle. And a leg is either one of the sides that make the right angle. Congruence theorem. If the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so here's some important points. I've got to make sure that I have a hypotenuse, which is this, and I have a leg, which is congruent, like this one here, and I've got right angles. I also have to make sure that they're right triangles. By definition of right triangles, I'm working with triangles that have right angles, and there's triangles with right angles, and that's by definition a right triangle. But I'm going to state that in the proof when I do something like this. So I've got an angle PRS and angle RPQ are right angles. Segment SP is congruent to segment QR. So that's marked here, and I've got my right angles. And remember, all right angles are congruent, and we're going to be good with that. But keep in mind, we don't go that route here. So I'm going to get my given down, and I've got that set up. And the first thing I'm going to go is for RP, or congruent to PR because of reflexive. And then I'm going to talk about these being right triangles, because remember, if one right triangle are congruent to another hypotenuse and leg of another right triangle. So I got to make sure they're right triangles. So I'm stating in my proof that these are going to be right triangles. And this is how I'd use hypotenuse leg. Either I'm given that they're right triangles in the given, or I state it in my proof by definition of right triangles. I now can say, because I have a hypotenuse congruent to another hypotenuse and a leg congruent to another leg because of reflexive, I can now say, step 5, PRS is congruent to triangle RPQ. I should say triangle PRS is congruent to triangle RPQ because of hypotenuse leg congruence. Okay, now that's what we'd be doing as a proof, and this was our first day, our first time with it, so don't stress out about it, but we got to make sure that we know they're right triangles before we can use HL. Now, as I'm going through, as I said earlier, we're going to be working with lining up corresponding points and being able to use systems of equations. For what values of x and y are the triangles congruent by HL? Now, if I do this, I've got my hypotenuse x plus 3 and my other hypotenuse 3y. So I got 3y equals x plus 3. I also have x, my leg, equals y plus 1. Now, keep in mind, this is an algebraic relationship, and we're going to be using something called systems of equations. You guys ran through this last year in Expo, but it's something that we use periodically throughout the year this year. Now, what I'm going to do, I'm going to take this relationship, x equal y plus 1, and where I see x in this relationship, I'm going to substitute it. So I'm going to set this up. I got that y plus 1 because it goes in for x right here. This allows me to solve for y. So I'm going to combine like terms on the left, and now I'm going to get the y's together over here and subtract y on each side and divide by 2. And I find out that y is 2. Now, I can go back in and find out what x is. If y is 2, because remember this relationship here, I've got x is equal to y plus 1. And now I know that y is 2, so x is equal to 2 plus 1. Because I substitute my y plus 2, and so x is 3. So my value here in 2a is y is 2 and x is 3. Keep in mind as we're going to use systems of equations and substitution. And this next one, we're going to line up corresponding sides, just like we have been throughout the entire chapter. 3y plus x is my hypotenuse. Y plus 5 is my other hypotenuse, so they're equal. Okay, and I've got a leg, y minus x, and x plus 5, and those are equal. Okay, Now, I'm going to kind of make this a little nicer. I'm going to get the y's on the same side. So I've got 2y plus x equal 5, and I'm going to get the x over here, or the x over there, so I can solve for one variable. And so I've got y equal 2x plus 5. Now, what I just did is I have two equations, these two equations, okay, set up for substitution. I'm going to take this one here, and I'm going to use this, and where I see y is going to be 2x plus 5. So I'm going to pop them in, and I've got this equation down here. Y is 2x plus 5 using substitution, and I pop that in. Remember, I got to do this because I want to be able to solve for one variable. Now I distribute, and I've got 2x times 2, it's 4x, and 5 is 10, and x, and 5. So now I combine like terms, I get 5x plus 10 equal 5. I'm going to subtract 10, and I'm going to divide by 5, and x is negative 1. And again, I need to find my y. Well, I've got y over here. Y is equal to 2 times, now x is negative 1, plus 5. Well, this is y equal negative 2 plus 5, and that's where y becomes 3. So my y is 3, my x is negative 1. I have my solution. X is negative 1, y is 3 here. Now, that's using algebra in systems of equations. In my next section, we're looking at, are the two triangles congruent? If so, write the congruent statement. So I'm going to look at this, and I'm going to check out my hypotenuse, my right angle. These are right triangles, and I got a leg that's 6 and another leg that's 6. Now, keep in mind, they're congruent by HL. And now I'm going to just count them up, and I'm going to start here at B of the right angle, and I'm going to go to A, then C, and I started at my right angle E, and I went to F and D. And yep, B, C, A, and E, F, D, those are great. And now this next one, I've got markings, and I've got a bow tie look, and I've got the hypotenuse opposite the right angle here and here, and I got my two legs. And this is going to be yes by HL as well. And I go ahead and do my triangle congruent statement. And you go ahead and try 5. Look at 5 for a second. It looks like, hey, I've got a hypotenuse and a leg, but are they right triangles? Do I have a right angle at Q and T? Since I don't, it's no congruence at all. And in 6, doesn't look like the hypotenuses are marked, but reflexive is our friend. RV is congruent to RV, right triangle. Got a leg, it's yes by HL, and triangle XVR is congruent to triangle TVR. Now our last ones, again, we're going to set up algebra, okay, in 7. Go ahead and give this one a try. This was pretty straight up. X was 17 because the hypotenuse and x are the same. Here in 8, I got the hypotenuse is 4.25, and the hypotenuse is 4.25, and my leg is x, my leg is 3. Find x. Okay, well, that was pretty nice because x is 3. Okay, in 9, just like the first ones we did, I have 13 is equal to 4x plus 1. Okay, I have 2x plus y is equal to 8x minus 2. Now, the thing that you got to keep in mind is 2x plus y equals 8x minus 2y. Okay, I've got to find x first. And this is all x, so I solved this relationship first, that 13 equals 4x plus 1. So I get subtract 1, I get 12 equal 4x, I divide by 4, and x is 3. Well, I take that 3 and I plug it into the 2x plus y equal 8x minus 2y relationship. So now I have x is 3, and I evaluate, and I've got 6 plus y equals 24 minus 2y. Now, I'm going to get my y's together, get that negative 2y over here, so I have 6 plus 3y equal 24. I'm going to subtract 6, and I get 3y equal 18, and divide by 3, and y is 6. So my values in 9 are x is 3, and y is 6. Do the same thing in the next one. Set up your x's, your hypotenuses, and set up your legs, and notice that the legs have a y in it, and the hypotenuse are just x. Solve for the x relationship, and then plug your value of x in where you see x in the other to solve for y. Go ahead, turn it off, and try it on your own.
Oh,
How you doing?
probably soft.
Now in 10, you have the hypotenuse here and this hypotenuse along with these legs. So my relationship is 2x plus 1 equals x plus 3 for the hypotenuse. And now I got to keep in mind I have my leg relationship, which is x plus y equal 3x minus 3y. Now, when I'm doing this, you got to keep in mind I'm going to solve for x first, use my value, and plug it in for x to find y. So I'm going to subtract x from both sides, and I've got x plus 1 equals 3. Then I'm going to subtract 1 from both sides, and I have x equal 2. So x is 2. So up here, I'm going to plug in 2 where I see x. But before I do that, I'm going to get my x's together and y's together on each side. So I'm going to subtract x, and I've got y equals 2x minus 3. I'm going to add 3y, and I get 4y equals 2x. Now at this point, I'm going to substitute 2 in for x to make my solving a little easier. So now 4y equals 2 times 2, which is 4. So I'm going to divide by 4, and y is 1. So in problem 10, my value of x is 2, and my y is 1. Okay, I hope this goes well. The assignment is the worksheet that's been handed out. Have yourselves a great day.